All right, folks, let us continue with 7.2. Apologize for the technology problems, but here we are. We're going to pick up with that last example, okay? We had these two theorems, all right? You should have these in your on your snow paper already. So this is the example that we lost connection with. We have a parallelogram, and we want to find x and y. And this is what our parallelogram looks like. We know it's a parallelogram because we have the parallel symbols on it. We have this side as 12. We have this side as 2x plus 4. And we have this as 7 and y. That first theorem we talked about today says that opposite sides are congruent. That is congruent to that. 12 is congruent to 2x plus 4. Those sides are equal. So all we have to do is take 12 and equal it to 2x plus 4 and solve for x. Minus 4, 8 equals 2x. Divide by 2, and that tells me x equals 4. Okay? So all you got to do is take the two sides that are opposite each other and set them equal to each other. Now to find y, it's a whole lot easier because these opposite sides are also congruent. Therefore, 7 is the same as y, so simply y equals 7. There's nothing more to do. Okay, so this will be like some of your homework problems. I'm going to do a few more examples with you, and then we'll look at some more theorems. This next example, we need to find a and b. We again have a parallelogram. What that means is both pairs of opposite sides of our quadrilateral are parallel. And then we have maybe this angle right here is 45 degrees. And then this one is 135 degrees. And this is A, and this is B. All right, this is like the second theorem we talked about this morning. Opposite angles will be congruent. This one is exactly the same as that one. So that tells me B is equal to 45 as well. And it looks like they're the same. Similarly, this is 135 degrees, as will this one be then. Since it's a parallelogram, A is equal to 135 as well. And that's as simple as that one is there, okay? When we have a parallelogram, opposite angles are congruent. All right, I've got one more example here, and then we'll go look at some more theorems. All right. Let's find H and M. Isn't that like a clothing store, H&M? Maybe. I might have bought a shirt from them one time. I'm not certain though. Let's say this side is 21. This side is 36 minus B. Then we have some angles here. This angle is H plus 7. And this is 112 degrees. Okay. And again, we know that this is a parallelogram. This is going to combine the two theorems that we have talked about already. Okay. Opposite sides are congruent. So when I look at 21 and 36 minus B, all you simply have to do is set them equal to each other. 36 minus B is equal to 21. Solving for this, I'm going to move the 36 over. So let's subtract it. That'll cancel it out. I'll get minus b is equal to negative 15. Okay. Now I want positive b, so just divide by -1, divide by -1, b equals positive 15. All right. Now when I need to find h is here. This is an angle. That angle is the same as that because opposite angles are the same. H plus 7 is equal to 112. If they're congruent, you just set them equal to each other. Subtract the 7. H is equal to 105. All right? And that is all you have to do to solve for H and M in this problem. Okay? Opposite sides are congruent, set them equal to each other. Opposite angles are congruent, set them equal to each other. Okay? So let's look at a few more theorems. This next one is theorem 7.5, parallelogram consecutive angles theorem. This says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so here again, what we know is that this is a parallelogram, A, B, C, D. This tells me that both pairs of opposite sides are parallel. That is the only thing I know. That is my if statement, my hypothesis. What I can conclude then is that consecutive angles are supplementary. What does that mean? That means when I take two angles that are next to each other, something like A and B, when I add those together, I will equal 180 degrees. That's what it means to be supplementary. These angles next to each other, A and B, equal 180. And it works all the way around. Measure of B plus measure of C equals 180. Any two angles that are next to each other that are consecutive, measure of C plus measure of D is equal to 180. And finally, measure of A plus measure of D is equal to 180 as well. Okay? So this tells me that angles that are consecutive that are next to each other, they add up to 180 degrees. So let's do a few examples that illustrate this. For this problem, let us find A, B, and C. I've got a parallelogram here. Both pairs of opposite sides are parallel. Let's call this A, B, C. And then this right here is 33 degrees. We're going to have to base it all off of the 33. All right. Now, angles that are next to each other. This 33-degree angle and this angle A, those angles are next to each other. That means that those two add up to 180. That means 33 plus A equals 180, or just 180 minus 33. And I will get A to be 147. All right. Now, A is 147. Now I can use one of the first thing we learned today. That is the opposite angles are congruent. That means A and C are the same. That means C must be 147 as well. So that's a 147. This was 147. And I don't have to do too much work to find B, because B will just be the same as the angle across from it, which was 33. And that is all you have to do for this type of problem right here, okay? And if I look at it, this is 33. We take any two consecutive sides, any two sides that are next to each other, you add those two numbers, they will equal 180, okay? So let's do another example illustrating this. With this problem, we want to find X. We have a parallelogram, as always. This is 3x minus 5, that angle. And this angle right here is 2x plus 15. We recall angles that are next to each other, like those two angles, okay? They are supplementary. They add up to 180. So all I have to do is take 3x minus 5 and 2x plus 15. And that should equal 180, and it will. And we solve for this, and we'll find out what x is. So solving this, we just combine our x terms. 3x and 2x, simply 5x. Negative 5 and positive 15, just combine your like terms. Negative 5 and plus 15 is just a positive 10, equals 180. Solving for x, we subtract the 10. Cancels, and we get 5x is equal to 170. You divide by 5, and x is going to equal 34. And that is how you solve that problem. So it's still using the theorem we just learned. Consecutive angles, angles that are next to each other, add up to 180 degrees. Okay, those angle measurements. All right. So I think we have one more theorem for you. Okay. This next theorem is the parallelogram diagonals theorem. This says if a quadrilateral is a parallelogram, then its diagonals bisect each other. All right, so we have this same hypothesis that we've had for all of our theorems on our snow paper thus far. Parallelogram ABCD. Now this is talking about our diagonals. Now our diagonals, they live from D to B. So I'm going to draw a line here from D to B and a line from A to C. And let's call this point where they intersect E. Okay. When we're talking about bisecting, we're talking about cutting in half. Okay, we're dividing it into two. What this theorem is stating is that our diagonals get cut in half. They cut each other in half. So that tells me that AE is congruent to EC, as well as DE congruent to EB. So what this would allow me to do, and I'm just going to take my markings and bring them over here in black, okay, that I could then put on my figure. That means that AE is the same as EC, as well as DE is the same as EB. In terms of numbers, if I was just to put some random numbers on here, let's say D to E happens to be 12. That means E to B must always also be 12. Now, it does not mean AE and EC are the same. Typically, they won't be the same. Maybe this is 7, which means this one would also be 7. But the 7s would match and the 12s would match. That's what this theorem is stating. Okay? So let's do a few examples here. Let's say find, let's draw a picture first, and then we'll find out what we want to find. F, O, R, D. We need our diagonals for this problem. Let's call this middle intersecting point S. We must know that's a parallelogram. This lesson is using parallelograms all over the place. But let's find FS and DS. All right, now what we know is we're going to know this. SR is 16. And SO is 21. This theorem we just talked about means our diagonals bisect each other. They cut each other in half. That means this is the same as that. That means this 16 is just going to transfer over there to 16. So I already know what FS is. Simply 16. We can do something very similar with DO, because this gets bisected as well, to where those two are the same. So if this is 21, I can just transfer that 21 over here as well, which means D to S, which is that segment there with that red 21, is 21 as well. And that is all you got to do, okay? All right, I believe I have one more example for you before I say adios. All right, so for this, let us find M and K. We know that this is a parallelogram. And then we have our diagonals coming up like so. And this one going this way. Now we know that this segment right here is 14. And this segment right here is 2K plus 6. This segment right here is 26. And this segment is 3M plus 5. And we're just going to do something very similar that we've been doing this whole time. Diagonals, these red pieces, these diagonal pieces, they cut each other in half. 14 will be the same as 2K plus 6. So all I have to do is set these equal to each other. 14 is going to equal 2K plus 6. And then all I have to do is solve it. Solve for this K, move the 6. And then we just need to divide by 2. 8 divided by 2 is 4, equals K. Similarly, these get bisected. That 26 is the same as that 3M plus 5. So you can just set them equal to each other and solve for M. Minus 5, minus 5. 3M is equal to 21. Divide by 3, divide by 3. This is the easy part, folks. M is equal to 7. And these are my two answers, okay? So that's about that. I'm going to put homework on Power School. If you happen to be watching this right now, I'll put your homework down here in the bottom corner in black. If you have questions, feel free to ask me, email me. We can get on the Zoom and make things make sense. 7-2, numbers 3 through 19. You guys have a wonderful day. Goodbye.